Hello guys, so we have a binomial distribution question here. If you are doing statistics, then this question is for you. A dice is rolled 9 times. Find the probability of getting a 4 upwards 3 times and less than 4 times. Now, we know when we talk of binomial distribution, okay, it deals with 2 numbers only. That's one thing that you need to know. All right. The first number is the probability that an event will happen, and the other number is that the probability of an event will not happen. So the probability of an event happening is called P, and the probability of an event not happening is called what? Q. At the same time, you need to recognize that the probability of an event happening and that of not happening should always give you what? Give you 1. Is it making sense? Okay, so here we are talking about infinity. It's a number of times you can roll something, for example, a dice. Okay, you can do it as many times as you want. So the question is, if you do something many times, what exactly are you looking for? That probability is what you are going to find, that is P. So we take into consideration 2 things. That is the probability of something not happening and the other one of happening. So 3 times. What do we need to know about this question? Okay. The first thing that we need to understand about this question is that there are on a dice there are 6 numbers and 4 only appears once. Okay. So let P be the probability of having a what? A 4 upwards. Alright, that means 4 only comes once, so P is equal to 1. And how many numbers are there, or how many sides are there on a dice? There are 6. So this is our probability. Then Q will be the probability of not having a 4, right, upwards, which will be 5 over 6. So we subtract 1 over 6 from 1, we get 5 over 6. Alright, so once these are settled, our N is 9, remember? And our R is just, you can call it R or X. It's 3 times. That is for part A. Okay, so how do we solve? We know that the binomial, the PMF, alright, is given by N, R. Okay, we have P, R, then we've got what? Q, N minus what? R. So in this case, our N is 9, 3. Then our P is 1 over 6 to the power 3. Our Q, we said it's 5 over 6. We have 9 minus what? 3. So here we get 9. This is 9 combination, by the way. This is 9 combination 3. So 9 combination 3, if I punch on my calculator, it's giving me 84. So here I'm getting 84 multiplied by, if I 1 over 6, so 1 over 6, then I raise that to the power 3, I'm getting something like 4 point something, so I'll just leave it the way it is. I'll punch it together. And here 5 over 6, then 6 there. So let's keep on multiplying. So 1 over 6, we raise to the power 3, multiplied by 5 by 6 to the power 6, then multiplied by 84, I'm getting 0.1302 as the probability of exactly, sorry, not 4 times, but 3 times. Okay, so now we can even conclude and say, all right, and say therefore the probability of having a 4 upwards 3 times, okay, is 0.1302. Then let's go to B. B says less than 4 times. So less than 4 times, ladies and gentlemen, it means this. So we have our PMF like this, all right, which does the same thing as less than 3. Do you agree? Because 4 is not included, right? But in this case, 4 is what? 4 is included. Okay, now because of this, that means, remember that binomial distribution, it runs from 0 and so on to infinity. So we are talking about probability of 0, probability of 1, probability of what, 2, and probability of what, 3. Okay, so what we are saying here is 9, 0, 1 over 6. What we put here? 0, 5 over 6. What is 9 minus 0? We still get what? 9. Plus 9, 1. Okay, 1 over 6. There are other ways we can find this, but let me just try to explain what is happening here. So we put 1 there, and we have 5, 6. What we put here? 8. Okay, 9 minus 1 is 8. We move on. We go to 9 and what? 2. Okay, then what we have here? We have 1 over 6 to the power 2. Then we've got 5 over 6 to the power, what is 9 minus 2? Get 7 plus, this one I'm just going to write it. Reason being is that we already found it here 3 times. For 3 times you already found it, so we'll just plug it in there. Okay, so what we need to find now is this and that one. Let's go. So slowly by slowly. Okay, please punch on your calculator nicely. So right, so 9 combination 0 is just 1. All right, so this is also just like a number to the power 0, you know, those things is just 1. So this is just 1, 1, and the only thing that we'll be dealing with is 5 over 6 to the power 9. So 5 over 6, all right, to the power 9. It's giving me 0.193. So I'll just write in decimal places 0.1938. I'll just end it there. Plus, let's call this one. What is 9? The 9 combination 9 is just 1. Sorry, it's just 9. Then you have 1 over 6. Just remain 1 over 6. Then you have 5. Okay, so the best thing that we have to do here is 5 over 6 to the power 8. So 5 over 6 to the power 8. Then we multiply by 1 over 6. We also multiply by 9. So it's giving me 0.3489. I'll just round it off. Then the other one is 5 to the power 5 over 6. 5 over 6 to the power 7. All right, so then we go to, so we say multiply by 1 over 2, 1 over 6 to the power 2. Then we're also multiplying by 9 combination 2, which is giving me 0.27908 plus this one we found it here, 0.1, 0.1302. Then we add this. That will be our final answer. All right, something closer to that, but that's a procedure. Okay, so we just add now. We have 0.1938 plus 0.3489 plus 0.27908 plus 0.1302. I'm getting 0.95 1, something like that, 2. So yeah, that's how this question is supposed to be found. But there are other ways of finding, especially part B, all right, where you take into consideration 1 minus everything that has been found and so on. But if you feel like you are bothering yourself to use the other way, just use this one. Especially if the numbers, the combinations are a few, just use this one. Nevertheless, the only thing that is here is the formula. All right, cheers guys.